cross out number, oh, you already did. I'm not worried about you doing 5. Look at number 4. We're going to cover this in just a minute once we get past this one. So that's like E, okay? So you don't have to do the last one. Okay.
Thank you.
I have perimeter and area written down for a reason. Marcus, please, dude. Thank you. This is the formula to figure out perimeter. You need to know this. This is on the test. Okay? You also need to know what area is. Okay? You need to know the perimeter equals length times width times 2. So length times 2 plus width times 2. Okay? So if we have this figure, A, and we're 4 and 2 on the side, we're going to take the length and the width and we're going to plug it in here. By the way, does it matter if we mix these up?
No.
It doesn't because the number's both 2, right? It doesn't matter. So 4 and 2 going in here. 2 times 2 is 4. 2 times 2 is 8. What's 8 plus 4?
12.
Yep. So our perimeter of this is 12. Let's talk about perimeter in case we haven't heard that word before. So Alex walks outside the door, right? He goes to the fence line in the back, walks all the way up the fence, walks all the way to the side to the corner of Van Buren, walks all the way back around and back through the door. What did he just do? He walked the perimeter of out back. He walked every side. That's what perimeter is. Okay? So this formula is saying this is 4, this is 4, this is 2, this is 2. If we add this together, that's 8 and 4, and 8 and 4 is what?
12.
Yeah, that's what perimeter means. Okay? Where area is just length times width. So 4 times 2. 4 times 2 is 8. So now we have this one. We take the 6 and 3, we plug it into the formula. 6 times 2 is 12. 2 times 3 is 6. Add them together, it's 18. Then if we're figuring out the area, length times width, 6 times 3. Okay, we're going to cover these tomorrow and these tomorrow. Okay? These two formulas and this formula, we'll get to this one in a minute. You're going to need to know for the test. You're going to need to know for the do now. Yes?
For the perimeter, is it always adding?
Adding after you multiply, yes. It's always going to be the length times the width. Now think about why you're doing this. If I know what the length is, I multiply it by 2, and I know what the width is, I multiply it by 2. Gentlemen, I'm recording. I can figure out what the perimeter is, right? So that's why we use this formula. Okay? Area is easier, right? Because it's just length and width. Perimeter means all the way around. Are we good so far? Yes, Eric. No. Okay, I have 2 cylinders here, okay? These are saying that these are similar in application. Eric, eyeballs, please. Remember I'm recording. Thank you, buddy. 4 and 6 and 3 and 2. Let's talk about radius. Does anyone know what a radius is? You take a circle and you go right in the middle and you measure it to the outside. If you do that, that's what your radius is, okay? If you know what the radius of a circle is, you can figure it out, okay? Now, if I take this 4 and then the 4 on the other side, that's 8, right?
No.
But the circle has parts of it cut off, right? It's not like a square. Like if this is a square and this is a circle, right? All this doesn't matter. That's why we use radius. Because radius is a better example of figuring out the area of the circle. Is that clear? And you'll get more into this in geometry. But essentially, this is the formula for volume. Okay? Pi, which is what? Can someone tell me what pi is?
Number?
Yeah.
It's 3.14.
And it's some number that doesn't always, it goes on forever, right? So we call that an irrational number. We can't really use it in math because it's a number that is constantly changing. Like it goes on forever and ever and ever, never stops. So we can't measure something that never stops. It's like infinity, right? So we treat this like it's a variable. Okay? We treat it like it's an x and we like it's a y. You also have this stuff in front of you.
Right.
Okay, good talk. All right. So we have pi. We're not going to do anything with pi. What's r? What do you think r is? Radius. So this radius is going to be 4. We're going to put 4 in here. That's an exponent. That doesn't change. That stays the same. Okay? So that's the power of 4 to the power of 2. And then our height in this case is 6. So we can actually figure out what the volume is. So we take 4. Do we do 4 times 2 or 4 times 4? 4 times 4 because it's squared, right? It's the base, Eric. It's 4 times 4, right?
We can times it together.
Yep, so 4 times 4 is 16, and then we have 6 as parentheses, so we're going to multiply 16 times 6, which is 96, then we just carry the symbol over. This is like the x, we can't solve for it, we leave it there.
Why don't you times by 3 times 4 times 4, but not 6 times 6?
Because there's no exponent on the top of h. That's an excellent question. This only applies to this, it does not apply to the h. Now let me tell you why. This is saying the exponent of 2. So 4 times 4, right? So that means the total area is 16. So 4 times 4 is 16, and that's why this is the power of 2. Because that's just 1/2 the radius. There's another half to it to figure out volume. So in the formula, pi radius squared times h is how we figure out volume. So the volume of this cylinder is 96 pi. Are we clear? Okay, this one's exactly the same. Okay? This one's 2 and this one's 3. So 2 is going to go inside of here to the power of 2 and 3. So 2 to the power of 2 is what?
4.
Times 3 is what?
6. No, 8. No, 12. Sorry.
Good, good. So 4 times 3 is 12. We carry the pi over, it's 12 pi. So our volume in this one's 12 pi and this one's 96 pi. Now look at the do now. What's missing?
The height.
The height. So this formula doesn't matter for this one. We're still solving the same thing, right? So we want 5 and 14. This one's the larger one, so it's going to go on the bottom. 5 and 14 at the bottom, and then 2 and x on the top. Do we see that? So this problem, even though it's cylinders, is the same as this one, same as this one, same as this one. But we could actually figure out the volume of this one, couldn't we? Because we have everything we need. We have the radius, we have the height, so we could actually figure the volume. Okay? So on number 4, I want you to tell me what the volume of this is, but I also want you to solve what that unknown side is. Is that clear? Okay, good.
So first to figure out what the
Hey, gentlemen, I understand we have noses and that sort of stuff, but it's during a lecture. Don't leave your desk during a lecture because I'm recording.
Okay.
I'm sorry, ask you the question one more time. Okay, any questions on this one? Remember, don't do anything with the pi. It's a variable. Just carry it over. Finish the math. Okay, so talking about this, these are all similar in application, right? So setting up this problem, it's going to be 2 and 5, right? 2, similar in application, 5, and then 7 and x. Cross multiply, divide. Cross multiply and divide. Cross multiply and divide. Cross multiply and divide. Cross multiply and divide. That's it. Are we clear? Good talk. Okay. Any questions? Anything I need to go through again?
No.
Okay. What's going to be on the test?
Cross multiply.
What else? What else is going to be on the test?
Applications of property.
Keep going. What did I tell you specifically was going to be on the test? What form? What's that?
The thing that you said.
Tell me.
The wheel. It started with the A.
Area and perimeter. You need to know these formulas. Okay? Those are going to... A question is going to be, what is perimeter? Tell me what the formula is. What is the formula for area? Okay? Now tomorrow, we're specifically going to work on perimeter area and volume. So we're going to practice more on this. Hopefully this is all down. Okay? I'd like to start with this example because I think it's an example that you can be conceptual with. Okay? Okay, get the do now done, turn it in. Remember, you're not doing number 5. The do now takes less than 10 minutes, and the actual worksheet takes less than 10 minutes because you're not doing number 5. Number 3 and number 4 are just like this one, and I don't remember what the last one was. Oh, and this one. This one. So this one is like number 4, and this one is like number 3. So set them up the same way, do them exactly the way the notes are. Okay? Mm-hmm. Okay, are we good?
Yeah.
No, not yet. Get your do now done.